Hi everyone, my name is Tanya Kashyap and I'm a second year student pursuing physics honors from Kalindi College, University of Delhi. This is my project assignment on automatic solar tracker for Skyfi Labs online course. So first, I'll start by telling you all what a solar tracker is. A solar tracker is a device that follows path of sun over the course of day or season to maximize energy output. Usually, solar panels or Fresnel reflectors are used to trap sunlight. A solar tracker is most efficient when it's perpendicular to the beam of sunlight. Now, this one you guys are seeing is an active and dual axis solar tracker, as it uses controller and light sensors and moves on both horizontal and vertical axis. Now, I'll explain each of the components one by one. Now this is a solar panel. It consists of set of solar cell modules connected either in series or parallel. Its role is to convert light energy into electrical energy. It works on the principle of photovoltaic effect, which is creation of electricity when exposed to light. These two devices that you see here on the solar panel are light dependent resistors. These are high resistance semiconductors whose resistance decreases with exposure to light. We are using two LDRs to increase the sensitivity. The first LDR is used to align solar panel in such a way that maximum intensity falls on it. The second LDR is used to search for maximum intensity of light. The both LDRs are placed on solar panel to detect its orientation with respect to the incident light, and then the signal is sent to the control unit of the solar tracker, which is the Arduino Uno. To affect the dual axis motion of the solar panel, motor driver and DC motors are used. Moving on, we have DC motors. A DC motor converts electrical energy into mechanical energy. Its output shaft is attached to a gear setup. Now, in the solar tracker, we use two motors. This one is the top motor and this is the base motor. The role of top motor is the horizontal axis rotation and maximization of intensity. The base motor is used for the vertical axis rotation and detection of light. This is a motor driver. It's an interface between microcontroller and motor. It's driven by L293D IC. Now I'll briefly explain its components. These are the input pins and these pins in the form of screws are the output pins. The first two pins from the right are connected to both the terminals of motor number 1 and the two pins from the left are connected to both the terminals of motor number 2. The plus V and minus V are used to power the motor. The input pins are connected to the Arduino. The enable A and enable B are connected to the corresponding motors, which are controlled only when they are high. Now input A1 and A2 are provided with signals that are necessary to run the motor number 1. Input B1 and B2 are provided with signals that are necessary to run motor number 2. The VCC and ground pins are connected to 9-volt battery supply. Now this is Arduino board. To know more about this, let's start with the question what Arduino is. It's an open source electric platform based on easy hardware and software development. It's a combination of microcontroller based Arduino boards, Arduino programming language and Arduino software for development and compilation. An Arduino board uses Mega series of 8-bit AVR microcontroller with on-chip flash memory for program storage. Here, in this Arduino, Mega 328 microcontroller is used. Now, a microcontroller is a computer on a single integrated circuit which performs certain tasks on a pre-programmed instruction set. Now, I'll explain each of the parts of the Arduino board. The TX and RX pins are the transmitter and receiver pins used for serial communication. The pins with the tilde symbol are used as pulse width modulator to control the servo motors. The pins from 11 to 0 are digital I/O pins. Now, the pins you see here from A0 to A5 are the analog pins. This is the Mega 328 microcontroller. This thing you see here is a 16 MHz crystal oscillator which acts as a clock for the board. This is the USB plug, which is the interface between board and computer, is used for uploading program onto the board and for powering in absence of external power source. This is the external power supply. The red button, which is seen here, is the reset button, which is used to re-execute a preloaded program. Now all these components are connected to each other with the help of connecting wires and a breadboard. The Arduino board is programmed to enable the solar panel to detect the light. To understand more about its functioning, let's look at a table. As it is clearly visible that pin number 4 and 5 correspond to the top motor and pin number 2 and 3 correspond to the base motor. When the voltage signal from Arduino is low in pin number 4 and high in pin number 5, the top motor rotates in clockwise direction. And when the voltage signal from Arduino is high in pin 4 and low in pin 5, the top motor rotates in anti-clockwise direction. When the voltage signal is low in both the pins, then the top motor stops rotating. Similarly, for the base motor, when pin 2 is low and pin 3 is high, the direction of rotation for the base motor is clockwise. And when vice versa, the direction is anti-clockwise. When the voltage signal from Arduino is low for both pins 2 and 3, then the base motor stops rotating. While programming the Arduino, we have to keep certain cases in mind. For case 1, let's say the light is incident on sensor number 1. In this case, the top motor must rotate the solar panel clockwise about x-axis until sensor number 1 senses maximum light intensity. For the second case, let's say no light is incident on either of the sensors on the solar panel. In this case, the base motor should rotate the solar panel in anti-clockwise direction about y-axis till light falls on any sensor. For the third and the final case, let's consider a greater intensity of light is incident on the second sensor here. In this case, the base motor should rotate in anti-clockwise direction until maximum intensity of light is incident on the second sensor. And then the top motor must rotate in anti-clockwise direction until this maximum intensity of light is incident on sensor number 1. All these cases are taken into consideration while programming the Arduino board, and the final program is uploaded onto it. Now that you all are aware of the working of the solar tracker, let's now power up the Arduino board and check the results. For the better demonstration of this project, I have dimmed the lights of my room a bit and I'm using the flashlight of my phone as the light source. Now let's see how is the solar tracker working. I'll slightly move the direction of my flashlight, and as we can see that the solar tracker's orientation is changing. As we saw that the solar tracker is working perfectly, so now we have come to the end of this video. I'd like to thank Skyfi Labs for providing me with this opportunity, for sending in the supplies and helping me build this solar tracker by assisting me at every step. Thank you everyone for watching this video.